Welcome to the TMC Newsroom. On location today on our show is Hunter Newby, and he is the founder and CEO of Allied Fiber, someone who I've interviewed numerous times before. Hunter, how are you?
Great, Rich. Thanks. How are you?
Great. Thanks for being here. So you're in the process of building out, as far as I know, probably the largest fiber run in the U.S. and probably the largest fiber run that's been built for many years.
Yes, that's accurate. We're doing that.
1,300.
Yeah, our phase one,
miles.
New York, Chicago to Ashburn, is 1,300 route miles. It intersects in Harrisburg, PA. It sort of looks like a T. A lot of people think of it as a triangle, but it's a multi-duct system following railroad rights-of-way through the U.S., and it is our phase one of the build. And you know, we've kicked that off, and it's going to take several more months to complete. Most notably because we've been collecting a lot of customer information in the process, which is very valuable to us at this point.
And there is just a bandwidth explosion going on between devices, video conferencing, telepresence, 3D video. The list goes on and on and on and on. All the things that are driving bandwidth. You're one of the companies at the lowest level. In fact, companies like yours that provide fiber are the way, or you make sure that the internet actually functions. So when people draw those diagrams of a cloud where everything connects to a cloud, at the end of the day, that cloud is really at its lowest level.
Yeah.
Lots of fiber in the ground.
Yeah, clouds are comprised of raindrops, and raindrops are physical things. So if you want to make sort of a parallel analogy, what we are building is at that lowest level. It's physical layer, raw infrastructure essentially, and we are a real estate company. We're essentially a landlord. We're not a carrier. We don't sell lit services, but we provide the physical fiber and physical co-location structures and power for equipment that enables not only a 1,300-mile long-haul network, but a parallel short-haul duct, which is essentially the intercept or the on and off ramp, where there's a separate fiber cable there that provides for access to wireless towers, access to rural broadband networks, access to schools, hospitals, community networks, anything along the way. And as you stated, there is a bandwidth explosion taking place. And there are requirements coming from wireless, coming from data centers, coming from all these other entities and network properties that exist that have no way to access from a high-speed and economically affordable, bit per cost per bit perspective. They can't access these systems because the fiber infrastructure that was built 10 plus years ago in the United States did not provide for that on-ramp, off-ramp concept or the neutral co-location facilities, which are essentially like meet-me room points. And due to the lack of those things, those folks in between the major metro markets can't get on to, ultimately, the internet at high speeds. And that's become very problematic, particularly for wireless.
So it's basically like having very high-speed highways that bypass entire cities and neighborhoods. And so they don't have access. They can see the highway. They just can't actually get onto the highway. So you're not only building this 1,000-mile plus highway, but you're also building, so let's consider that the express lane, but you also have the local lanes where people can get on and off as exits and entrance ramps.
That's exactly it. And the interesting thing is that because our system is designed the way that it is, we're doing deals now with the major carriers and the major network operators, non-carrier network operators, and their fiber and co-location requirements associated to run a long-haul system are large, borderline enormous. We're talking about dozens of fibers for each of them that we're incorporating into our initial design. So this window of opportunity that we're in right now, before we make the final decision on the fiber cable type, different types of fiber, the count of fibers, the co-location structures themselves, how big they should be, the power infrastructure. There's basically two types of fiber, power, AC and DC power. So how much UPS, how much battery backup, how much generator backup do you need? Those requirements expand as we learn about new customer opportunities. But that express and local lane, the local lane is interesting because there are a lot of island networks out there, particularly as a result now of the stimulus funds, where they're funding basically islands that have no backhaul.
Right.
And those folks are now coming to us saying, well, we're going to build out this large community fiber network, but now how do we get to the next biggest city?
Right.
So those people are coming to us with requirements for short-haul fiber, which will only be 20, 30, 40 miles, 100 miles, something like that. That marries with the long-haul major city pairs very nicely in our co-location facilities. And we're seeing an interesting dynamic take place. all of these demands, towers, data centers, all of that pours into our route. And it's important for us to learn as much as we can about what everybody needs now, so the final product that we deliver fits the immediate needs and the projected needs of each of those network operators for the next 12, 24, 36 months at least.
And if you're a company that's looking for fiber right now and you need to interconnect over distance, you've got to work with someone like you today to help specify the sorts of fiber and the sorts of I guess splicing issues and just connectivity issues or connectivity points that you would need to get onto that network. So in other words, unlike traditional carriers where they set a lot of the parameters, you are actually working with your customers to allow them to set the parameters.
Correct. Yeah, there's two things in what you said that are very important. The first is that the networks that exist, carrier-owned networks, are what they are, and largely they've been there for 10 years. So there's no way to bring your specific demand requirements to them because you're basically buying off the shelf whatever's there. That's if you can get it, because carriers typically on the long haul don't lease fiber as a dark product, and also their co-location facilities are highly restrictive, if not impossible, to get into. And therefore, it's a moot point to try and say that you could give specific requirements for colo and power if they won't let you in. The flip side of that is, yes, we are openly working with network operators to obtain their specific requirements to essentially custom build their own fiber network, comprising long-haul elements, short-haul elements, co-location space, and power, access to towers, in a design that we can roll out. You mentioned splicing, very important point. There are certain applications that may not need an intercept everywhere along the way. Certain applications are latency sensitive. Video is a really good example. High bandwidth capacity things where they want to shoot light a greater distance than a normal, which our co-location facilities for regeneration are spaced every 60 miles. Some folks are coming to us saying, no, splice my fibers through every other site. I'd like to shoot light 120 miles. That's not something that you can get custom built from an existing network because it is what it is. We are accommodating people with those types of requests. Also, larger power type requests. Our facilities are meet-me room type facilities, and for those people that aren't familiar with what a meet-me room is, it's more of a carrier interconnect facility, not a data center. The data center type environment is totally different.
Sure.
Higher power, higher cooling, higher densities within the environment, but still a very large need for fiber and high capacity transport services, wavelengths and such. So we actually now are starting to see very real examples of data centers being built directly on our route. Because finding space and power mostly isn't the difficulty, it's finding the dark fiber in addition to those two things. The land I meant. If you find land, you can find ample power, 10, 20, 30, 40 plus megawatts, diverse substations, but then there's no fiber. How do you get fiber there? So our fiber, the entire route, is accessible along the route. So you could put a data center wherever you can find the space, the land, and the power on that route.
And then just connect up to...
And then we'll just tap right into either the short-haul fiber or directly into an allied fiber colo facility where that data center operator or the transport providers to it can place equipment.
So this is really an opportunity for other data center companies, new ones, to look for low cost or, let's say, new data center locations, which may serve metro areas that are currently underserved.
Precisely. And they're underserved because of the fact that there isn't any dark fiber that could be leased that goes all the way back to an existing U.S. major interconnection network peering point. New York, Chicago, Virginia, generally speaking, those are the areas. It covers a great distance. Well, what about a data center in eastern PA? What about a data center in Harrisburg or western PA outside of Pittsburgh or Cleveland or Toledo or anywhere in between any of those markets where there's a lot of power and there's a lot of land, but there just isn't any fiber that you can get? We add a dimension, the third leg to that stool, that makes it possible. There's also container data centers, this whole new concept.
Sure.
Containerized data centers could be placed anywhere along our route.
So that's just a concept of you basically ship it, you just drop it, and it's just a data center just in a box.
Natural gas and diesel. Many times we can get three-phase power because we have access to three-phase power. It's a data center in a box. This isn't the grandiose million-square-foot site, and there are places for those.
Right.
But hey, look, everything has a place in the world.
Sure.
And the fact of the matter is, those local universities and the hospitals and the office parks that are 100 miles from nowhere today, they have server data center requirements. They're presently hosting those things in their phone closets
Right.
or in their basements. They need reliable power. They need access to high-speed circuits and/or dark fiber, and they need it, economically affordable. Not everything can be totally outsourced. They do need some things that are local, and that type of concept with a master land lease that we have with the railroad, we can bring the container data center to the site and have it tied directly into our Allied Fiber meat facility, where the short haul and long haul fiber exists to take them anywhere else throughout the country.
So is it fair to say that you're adding value to this land, which didn't have as much value prior to this point? Because obviously the necessity for broadband continues to grow. I mean, it's exponential growth. The need for data centers continues to grow. A lot of things are moving to the cloud. So is it fair to say that along the route that you happen to be building, that the value of land within reach of fiber to your facilities or to your long haul is now increasing? Is that what's happening?
Yeah, that is accurate. The value of the land is increasing. The value of the surrounding land is increasing. The value of the land of the United States of America is increasing. We, as a country, need to make a very logical and educated investment in this type of infrastructure. Not just fiber, power infrastructure, water infrastructure, all types of utilities. And we need to preserve the land that we have and use it in a proper way, a very smart, intelligent way. And our design provides for that. So the people that want to take advantage of it can, because if they have adjacent land or land that's nearby that has power, we can help them appreciate the value of that by attracting people to it that otherwise necessarily would have never gone there.
That's very exciting, and it's good for the country. It's really good for the country that you're...
It's going to help us keep up with those smaller countries that are currently ranked higher than us on the OECD list.
Sure, for broadband, right?
Yeah, for broadband penetration and speeds, because they're small. The issue
Sure.
is that because they're so small, they can do a CapEx investment and the country's broadband speeds and penetration rates go up.
Right.
And it's very affordable because the CapEx to build it was very low.
Sure.
So the ROI is a lot closer. The United States as a country could encompass Western Europe and parts of Asia.
Right.
That currently, as countries go, outpace us because of our size and the challenges with trying to figure out how to finance the construction of the physical layer assets that drive all of those networks.
And then you've got